Okay, welcome. Thanks for coming. My name's Tim Morgan, and I'm an application penetration tester. I've been doing it for quite a few years, and the way I keep it interesting is by doing research and trying to find new techniques, learn new things all the time, and I love to collaborate on research. So if any of you have a burning idea and want to chat about it, I'd love to hear it. My current areas of research are obviously XXE attacks, application cryptanalysis, and IPv6. I'm the chapter leader in Portland, Oregon, so if anyone wants an excuse to come visit the beautiful city of Portland, then let me know and maybe we can have you as a speaker. Okay, so I'm probably going to talk pretty fast to get through all my content, and I may not have time for questions at the end, but feel free to grab me afterwards. I'll be either here or at the speaker's room. So XML is all over the place, right? It's in everything. The more you look for it, the more you find it. And a lot of people are surprised to find it in places like, well, for one thing, SVG is an entirely XML format, but also in most image formats have the option to have XML in the XF headers as part of the metadata. And it's obviously in a lot of networking protocols. All your document formats basically use XML now in one way or another. And so any security issue that affects XML, either from a design perspective or because it affects a popular parser, then that can potentially affect a lot of different pieces of software, right? And a lot of people don't even realize that their applications are parsing XML sort of under the hood because they're relying on a library that parses something that has XML in it, right? So it's kind of a hidden risk sometimes. One of the well-known risks of XML is entities. So entities are a feature of DTDs. DTDs are document type definitions, and those are a carryover from the old days of SGML. And those allow you to define the structure of a document, an XML document, say what tags it should have and what other kinds of information it should have in it. And it's almost more of a syntax definition, right? It doesn't define semantics. It just says this is what the structure of the document is going to look like. And entities are a feature that basically lets you do sort of macro substitution. So you can define some sort of bit of syntax, of XML syntax, as a name, and then reference that name within your document multiple times, and it will just do that automatic replacement. Okay, so that's all an entity is. However, they created this whole idea of external entities. Okay, an external entity is something where you can create an entity that references a URL of some kind, and then it will fetch that URL and use the content of that URL as the content of the entity. Okay, so that's clearly a risk because then people can basically steal files. They can cause the XML parser to reference, maybe grab a file document off a web server and include it in the document, and maybe something bad could happen there, right? So people have known about this for a really long time. Back in 2002 was the first bug track posting that I remember, and the earliest that I could find, that somebody pointed out all the different things you could do if an application accepts XML from an untrusted source and supports a lot of these features, then he had, basically Gregory Stoik had a great summary of all the different kinds of attacks that might be possible. And he was kind of just scratching the surface on this, but he did a great summary of all the different sort of starting points, avenues of attack. Despite being well known for a really long time, it seemed like research in this area died for a number of years. And maybe it's because the XML parsers that were popular then sort of turned off the features by default, and you rarely found the vulnerability anymore. But then more recently, the more popular parsers today now support a lot of stuff by default. And so I personally find XXE vulnerabilities in probably half of the applications that accept XML. They're extremely prevalent, okay? So some of the things you can do with entities attacks, for instance, are, you can invoke arbitrary URLs, right? So from inside the network, once you manage to invoke URL, you can do cross-site request forgery-like attacks. So suddenly you can send requests to internal web servers. Okay, that may be interesting. But of course, you kind of need to know what you're targeting in order to do anything useful there. Denial of service attacks, the more you look at XML and DTDs and schemas, the more you can come up with denial of service attacks. There's so many different ways that you can do resource consumption. The most well-known one is the billion lapse attack, where you essentially recursively define entities. One entity refers to two more, and those refer to two more, and so on and so forth. And so once you instantiate one entity, then it can take up all the memory on your system, like just by referencing that one top-level entity. Okay? And that all happens, of course, within the XML parser before the application has an opportunity to actually do any kind of validation. So the application can't do anything about it. And then some people have talked about using XXE attacks in order to leverage third parties to attack particular sites. So if you find an XXE vulnerability in a third-party site and you want to target, I don't know, PayPal or something, then you can just use them as intermediaries to attack, right? Personally, I don't really care about denial of service attacks, so I don't focus much of my research on it. Data theft. So if you have access to external entities and you can force an XML parser to include a document in the XML file, then you can steal that data so long as the application behaves a certain way. Okay, so basically the way that works is you pull the data in to your document, and once it's included inline, then the application will interpret the data, right? So usually what you'd want to do is convince the application to store that data somewhere, and then later you need to come back and fetch it from the application and convince the app to cough it back up. Okay, so this is the traditional external entities data theft scenario, right? So this is obviously limited. Well, okay, let me give you a quick example of what it looks like. So here's an XML document. You basically put the doc type, which is your DTD, at the top. You include a definition of an entity, and you define the file entity. Okay, that's your name of your entity. You're pointing it to a local file, the Windows INI file. And then within your document, you're including a reference to file, and it's just going to cause that data to be pulled in and dropped right in that last name field. Okay? So you could imagine in this example that perhaps an application is accepting some sort of XML RPC-like request and is allowing you to update your own profile through that XML RPC request. And then, but all that means is that that data will be stored still on the application side in your last name field. Okay? So later you need to come back to the application and view your own profile, and then you can see that data in the last name field. Okay? So it definitely is limited in that you need to convince the application to cough the data back up. It's also heavily limited in terms of the types of data you can steal. Okay? Binary is out of the question. Okay? You cannot pull in binary because that's not valid XML. In fact, any entity data, anytime you map data to a regular entity, that data must be a well-formed XML document. Okay? So if you have any stray, XML special characters in a text file, then that can break the inclusion. Okay? So that's limiting. And you can actually include well-formed XML documents, but once you do that, in this particular attack scenario, then the application is going to go try to interpret that last name field, find like a whole series of more tags, and it's either going to fail validation or it's not going to pull the text in as raw text. It's going to pull in any data around the next set of tags. So you don't actually get access to the data. Okay? So it's heavily limited, right? So because of that, I think a lot of pen testers get turned off to using XXE attacks or to rating these as serious issues because in practice they find it incredibly difficult to actually steal data. Okay? Once in a while you can pull back a password file, a few basic configuration files, but if there's any special characters in there, you're kind of lost. And vendors, their approach often, the XML library vendors or API vendors, they tend to take the approach that, well, we'll just provide a way to turn off external entities, and developers can do that, which of course never really happens. Most developers have no clue entities exist, right? It's a legacy feature, and most of the time, a new developer might be introduced to XML schemas rather than DTDs, and they don't even know that DTDs, they may not know how to use DTDs and that they have all these features in them. So it's really common for developers to forget to turn that off. Also, a lot of vendors, in order to mitigate denial of service attacks, like the billion laughs attack, they take the approach of just putting resource limits on the size of an entity or on other types of recursive operations, and then they think that's going to be enough. But as it turns out, the URL schemes that are available in a lot of XML parsers can allow for a lot of other denial of service attacks that I think they're really not considering at this point. Okay, so moving on to a lesser known type of entity. There's these things called parameter entities that come along with DTDs, just like regular entities, but they are only usable within the DTD itself. So it's like a syntax replacement macro just within the DTD. Okay? And to define those, you put a little % sign here, okay? And that just says this is a parameter entity. And then this is the name of your entity. And then you can actually put in a DTD syntax, okay, as your value. And then you reference it right in that DTD, which then writes it and then reinterprets it immediately as more DTD syntax. Okay? So that's pretty interesting. And so in this example, I'm actually using the more syntax parameter entity to create a foo regular entity, and then I reference foo regular entity down here. Okay? See that chain of events? So that works fine. Now, forgetting about parameter entities for a moment, let's think about this. Now, before I said if you have a text file that you want to steal, but it has XML special characters in it, so it's not a well-formed XML document and it's going to break during the parsing step, wouldn't it be nice if we could do something like this? If we could wrap it in C data tags, right? And then you can then include that. Most of the XML special characters will be ignored, and then you could maybe actually steal that data. Turns out this example doesn't work at all, okay? Because once again, any entity must be well-formed XML, which means those C data start and end tags are not well-formed. So it actually blows up on those first before you can continue, okay? But with parameter entities, we can pull that off. It gets a little complicated, okay? The chain of events is long. But what you do is you define your file, start, and end entities as parameter entities, which has less restrictions on the syntax, okay? And then in order to make this work in any parser I've tested, you actually have to reference an external entity, an external DTD document, pull that document in, and then reference your parameter entities within the secondary document, okay? And then that allows us to create this all regular entity, and then from that point, you would just include all in the document, and that works fine. At least in Java, for instance, and variants of this work in .NET, and I haven't tested all the parsers for this particular technique yet, but it definitely does work. And what this basically gets you is that now you can not only pull in well-formed XML documents, but you can actually read them, right? You can actually treat them as text and retrieve them and do whatever you want. You still can't get binary, right? Still can't do that. It still requires that the application can cough the data back up to you somehow, right? So the XXC happens, it stores that stolen file somewhere, and then gives it back to you at some point. It also requires phone home access, which is what I mean by that is that the application server has network access back to you. Because, of course, I had to supply the join.dtd file, right, as my secondary bootstrap for this process. Okay, so there's an added limitation there. Okay, but if we can actually dynamically define entities in the DTD, in other words, we can piece together entity tags or entity syntax in that context using parameter entities, why can't we just build an entity tag that actually is part URL and part file contents? And in fact, we can. And the first guys to publish this published earlier this year at Black Hat. And this is how it works. Same sort of approach where you pull in your file data as a parameter entity. You need to grab a secondary DTD file, and from within there, you define a parameter entity which includes the syntax of another parameter entity, in this example at least. Here you'll see this is an encoded %, okay? Had to be encoded in this context. So this here is a parameter entity we're defining called send, and it's going to reference this URL of the evil host, right, of our own machine. And then we're going to dump the file contents right here, and then reference all, which then, of course, writes this here, and then later we can actually reference send here. Okay? It's kind of circuitous, whatever. But the great thing about this is notice there is no XML here. Okay? There's no document. So this actually all happens before the document is validated at all. And so we can ship all that data back to ourselves before the application even knew it happened. We don't need to, store it and then retrieve it later. So basically, as soon as you send this, it's coming back to you via URL to your web server. Okay? So this is really powerful. There's still limitations, though, of course. Still no binary. Okay? And because of the way that we had to define the syntax and we had to, wrap the one entity in double quotes and the inner part in a single quote, if your content contains those, that can cause breakage. But usually you can choose whether or not double quotes or single quotes breaks, your attack. Okay? Also, because we're dealing with URLs and we're putting the file content there, anytime you have a hash, that's going to truncate the data because that's a special character in URLs, and you won't see anything after that. It, of course, also requires phone home access, clearly, since we're shipping it back to our own web server. Okay. The other aspect that I think a lot of people are ignoring, particularly vendors, is that the URL schemes that they provide from within their XML parsers, in other words, FTP, HTTP, HTTPS, all those schemes, those actually provide a lot of power, and depending on the schemes that are provided, you can do a lot of crazy attacks, which I'll be covering a number of those. And these, in some cases, you can use those schemes without external entity support at all. You can force an XML parser to actually retrieve a URL without external entities being turned on, okay? And I'll show that in an exploit I have in a minute. These are the schemes or protocols supported by some popular platforms. libxml2 is very limited in terms of what it provides and what you can do with it, and a lot of open source software uses it. However, you can override the handler that parses URLs, and that's exactly what PHP does. So PHP is libxml2 based, and they open it up to provide all of the URL handlers that are available in PHP, which is an extensive set. And the stuff I said earlier about you can't steal binary data, yes, you can. Because with PHP's URL syntax, you can add filters to the data to where just within a URL alone, it will read a file, encode it as base64, and give it back to you, which then you can embed in your document or send over via a secondary URL. So with PHP, it's extremely powerful and scary. Java also has some really interesting features, and I'll be going through each of those that, a series of attacks against Java URLs. .NET is quite a bit more limited, but in general, the parsers act quite a bit like Java's. Okay, so in Java, one interesting fact is that the file handler actually gives you directory listings. This is so awesome when you're attacking. You just point it to a directory, and it gives you a new line delimited list of all the files. Okay, that is sweet, because then you can just look around on the file system and find out what they have for config files or other sensitive data. Older versions of Java actually support the Gopher scheme. Okay, does anyone remember using Gopher? Okay, I don't. I guess I'm not quite old enough, or I wasn't using the internet early enough. So Gopher is a really old protocol that is really simple, and you can actually utilize that to send arbitrary data over a TCP connection. And I'll give an example of that. And also the jar handler is a special Java thing. Well, I'll come back to it, but can allow you to peek inside of zip files and also upload files to the server. So with Gopher, the way that this occurs, the way that you'd use it is that the first character in the path for the URL is just some special number that instructs the Gopher handler to know what data type it's going to receive. So you kind of have to tell it, oh, you're going to receive a menu, or you're going to receive a binary file when you hit this URL. So it's just a weird syntax, and generally you can ignore that, although it does control how the Gopher handler interprets the data that comes back. But the interesting part is in this request bit, you can send arbitrary binary data here if you just URL encode it. So %00, sure, it's going to go null right over the network. It's going to decode that and send it. And you control the very beginning of the request, the very first byte that's sent over that TCP connection, and anything after. So you can do great things like send a post request to an internal web server. So not just a URL, but a full post body with any HTTP headers you like. You could play with WebDAV. You could do anything you can think of on an internal network. You can send a block of data at it. Limitations. Well, fortunately, Oracle was paying attention. And in 2012, at Black Hat, somebody pointed out that you could use Gopher for some fun things. And then several months later, they're like, why do we still have this? And they disabled it. But in my experience at least, a lot of web applications still run on very old versions of Java, because a lot of admins don't really perceive Java as being vulnerable on the server side. When there's a weekly vulnerability in Java, they all think about that as an issue in the browser alone. So a lot of times, in my experience at least, it doesn't get upgraded very often. Another limitation is that the requests from Gopher are single shot. So in other words, Gopher is going to take all the data you gave it and just send it all as one block, and then it's going to retrieve a response and quit. Okay? So you can't do some sort of complex TCP handshake. You can't do a more complicated conversation. But for things like HTTP and a lot of other protocols, you can still do a lot. And it's pretty difficult to retrieve meaningful data from Gopher, except maybe success failure of your request. Okay, so jars. The jar handler is designed to allow you to grab some file that is supposed to be a jar file, and then retrieve a file from within the jar file. Okay? And so it doesn't actually do any validation of the inside of the jar file. Once again, I guess, in case you didn't know, jar files are just a zip file. That's all they are, with special files inside, right? They have certain manifest files and all this other information in it. But this handler doesn't really care about any of that. All it cares is that it's a zip file. So what you can do is just include a URL of any zip file and then retrieve a file from inside of it. So once you've already got directory listings, and let's say you're on a Windows machine with Java, then you could easily use those directory listings to start poking around on the network using UNC paths and looking at different network shares, maybe find some Word documents. You can't steal a Word document directly, right, because it's binary. But you can poke inside of it, because Word documents, docx at least, are zip files, and pull out the XML content from inside of there, right? So you can still get at the data. Because, of course, the jar handler has to decompress the data, you could use this in denial of service attacks with a decompression bomb, that kind of thing. Haven't really explored that a whole lot. But the cool part about this is with jars, with the jar handler, you can put in any sub URL within the jar handler in that spot that's shown there. And so if you retrieve a remote document from a web server, then what does Java have to do? Right? It has to go grab that file, download it to a temporary location, parse the zip headers, pull out the file that you asked for, right? And then it goes ahead and deletes the temporary file. Well, so what that means is essentially you can force it to pull down a zip file from your own server, store it temporarily, and so you've effectively uploaded that file to the server, okay? And then it's going to turn around and delete it quickly, right? Well, we could try to find that file on disk by using directory listings, right? We could start working through the temp directory and try to find it, and then maybe we could use it in some attack and try to win some race condition while it's processing the zip file. And it turns out it's really easy to do that, because if you control the web server, you can simply have it pull the file down, you give it all the content, and then you just hang the TCP connection. You intentionally hang the TCP connection, that temp file just sits there waiting and waiting. Meanwhile, you do more XXE attacks to do directory listings, locate the file, and now you could use it in secondary attacks. For instance, you could do local file includes or directory traversal issues maybe that are already in the application elsewhere. So it's one little building block, right? You can upload anything. You don't have to upload just zip files. Of course, Java doesn't bother to parse the header of that file until it finishes downloading. So until it finishes downloading, it's anything, right? So you can literally upload any content. But you can't control the location of the file, clearly. It's in a temp directory. And you can't control any part of the file name or extension, okay? But we can locate it. Okay. So I'm going to show you a remote code execution attack against a moderately reasonable scenario. So we have an older public web application in this scenario. It's running Tomcat and an older version of Java. And it also has the Tomcat admin interface running, but that's only accessible internally, right? It's not exposed to the internet, which is a common setup. There's a load balancer that brokers that access, and the application that is deployed publicly does have an XXE flaw. Okay, so this is kind of our setup. As you can see, we have the internet, we have our load balancer, the vulnerable application, and the admin interface, which is isolated network-wise. Okay. So, can anyone think about how we could stitch together a bunch of techniques in order to compromise this system? Okay. So here is our vulnerable application. It's really cheesy, and it gives you back all the information you want, which is an ideal case, of course. But here is where I'm bootstrapping that setup to wrap things in CData tags, so I can retrieve more content. So here I'm just putting in a file URL. This is the important part. Putting in a file URL just to list the root directory. Okay. So this is going to give us directory listings. If I can get down here. Okay. So here is the root of my laptop's file system. All right. So you can imagine an attacker would poke around for a while, looking in lots of directories, looking for interesting stuff. But after a while, maybe he'd find the Tomcat 6 directory. Okay. And then our Tomcat users.xml file. And see that, sure enough, they actually did set up a user that has rights to access the Tomcat admin interface. Okay, so that's really tantalizing because, of course, from the Tomcat admin interface, you can load new web applications that can execute arbitrary code. But we can't access that interface. We don't have direct HTTP access to that. Okay? So, but what we can do is we can upload a file to a temporary location on the server, use Gopher to invoke the proper interface on the Tomcat admin, web interface, cause it to pull in that local temp file and install it. Okay? So I'm going to run an exploit now that has that all scripted. So there's a Python script that's the exploit, and then there's the evil.war that we'd like to upload and deploy. Okay, so and this thing's wrapping badly, but I'm just going to specify the WAR file I want and the credentials. Okay. The only reason it runs that slow is that it waits to make sure the file got uploaded fully. So if we start at the top, I'm not going to show you the script because I don't really have time, but if I could find my mouse. Anyway, so at the beginning, we set up our own malicious web server. Okay, it's a custom web server that's listening on that port. And then we submit an XML document to the vulnerable interface. And notice here, I'm not actually doing any external entity attack here. All I'm doing is putting in a doc type that has a jar URL that says, hey, your DTD for this document or your schema is over there. Okay, so I'm actually invoking the URL handler without external entities at all. And so that's going to force it to fetch from my web server on that same port the evil.war file. And then jar is going to spool that locally for a while, right? Well, my evil HTTP server is going to send all the data and then just hang the TCP connection. Okay, so the data is there. And then I am going to use a real entities attack here to try to list the directories in the Tomcat temporary folder. Okay? And then it quickly locates that, and that is the temp file that it stored locally on the system. Okay? And then what I would like to be able to send, because as an attacker, maybe I set up Tomcat manually and work this out. But in order to deploy that WAR file, I need to send a request like this to the admin interface. So here is the GET request. And I do need to be able to send a basic authorization header. Okay? Java does not support doing http://username:password @ It doesn't support that for HTTP. It does support it for FTP. So since it doesn't support that, this is the only real way that in this context I can include that header is by using Gopher, right? So in the URL we have evil.war and the local temp file. This particular interface will not let you specify a URL to retrieve from a remote source, which is, of course, a good idea, right, in the Tomcat admin interface. But because we were able to upload a file, it doesn't matter. Okay? So we invoke that. And down here, so that's the request we'd like to send. But, of course, that's sent from the XML parser, right, to the Tomcat admin interface. So here is the actual encoded version where we've embedded that entire GET request in the URL. And once again, this is not an XXE attack. There's no entity there. Okay? And then after it got in there, then we ought to be able to see our new evil deployed application over there. So let's see if it showed up. Let's see. I can barely read this, but okay, it worked. So basically, that evil.war file contained a JSP script that executes arbitrary commands and echoes them back to you, right? So I can do. I don't know if I typed that right. I didn't. I cannot see this. Oh well. Oh well. Anyway. So we can run remote code. Now, I forgot to show you earlier that here is what I had for this Tomcat admin interface before I ran the exploit. And you can see through here there is no evil.war deployed. So there's no man behind the curtain. I didn't already have it set up that way. But now if we just list it again, then you can see evil and evil.war are here. The reason that it shows up twice is because I'm using a trick to fool Tomcat into loading a WAR file that does not have a WAR extension. So it's a bug, basically, in Tomcat, and it still let me deploy it, and it just shows up twice. Okay. Okay, so just as a quick overview, again, this is what this script did, so you can see it in pictures. So initially, we rummaged around, we found the credentials on disk. And then we used the jar handler to upload the WAR file to a temporary directory. And then we stalled that connection, and we rummaged around more to find the location of the temp file. And we keep that connection stalled while we use Gopher to invoke the Tomcat admin, load the file locally, and then deploy it as a new application and prop it. So obviously, that's a slightly contrived scenario. I relied on the fact that we have an older version of Java. The rest of the assumptions are actually fairly common for deployment. But you can also imagine that in place of Gopher, you could use a CSRF attack against any internal user and probably pull off the same thing so long as you can get the timing right. So there's actually, the thing about XXE is that it's a lot of little tools for an attacker. If you expose it, there's lots of little different things you can do. None of those is particularly powerful. Okay? But when you pull them together, that's when things get really scary. And so you can both combine all these different tricks just from within XXE or other vulnerabilities in the application and come up with nice exploits. You see this a lot nowadays in other mature areas, like with browsers, with overflow vulnerabilities, or in other areas where you never get one vulnerability that gives you a full exploit, right? You always have to stitch together a bunch of little things, information leak here, an overflow there, and actually pull it off. So I think it is underestimated for that reason. XML is changing a lot over time, and new standards are being introduced. There's all kinds of other crazy features that people have standardized that aren't on by default in a lot of parsers, that if they ever become on, it would be way worse than what I've been showing. So recommendations for developers. It's actually hard as a developer to fully protect against all of the techniques that I've come across. But you really need to know your XML library, and you need to know how it behaves in terms of what it has on by default, whether it has entities, external entities, what kind of URL handlers that it supports, and turn everything off that you can. The vast majority of developers do not rely on these features, and so you rarely are going to have a problem if you turn things off. And then if you know there's certain things you cannot mitigate, and in some cases the libraries don't give you an option to mitigate them, then it's a hack, but try pre-parsing input validation. So before you parse the document, look for the obvious syntax that leverages a feature that you're worried about. And then block network egress. Don't allow your web application to connect out to arbitrary systems on arbitrary ports, or any port, right? Because any of these connect back to attacks, you can put them on any port you want. And so by doing that, block the network blocking, then it makes it a lot harder to bootstrap a lot of the attacks I was showing, where you have to use a secondary DTD file to pull it off. In the long term, vendors are the only ones that can really stop these issues. Anytime you have stuff that's on by default and nobody knows that it even exists, you're going to have plenty of vulnerabilities, right? And I think vendors have been really resistant to turning things off for a variety of reasons. But I think we just need to continue to pressure them to do so. I would really like to see that inline DTD parsing be disabled by default. I mean, to me, it makes absolutely no sense for you to accept a document from a potentially untrusted source and ask that person to describe for you what the syntax ought to be for that document. I mean, why would you do that, right? I mean, the whole point is input validation, and DTDs are very powerful, and schemas are very powerful to help you validate your input, and they're a great idea. But why would you trust them to do it for you, right? And even if they were describing some document syntax that was different than what you'd normally expect, how are you going to interpret that, right? I mean, if you have different tags in there that you don't expect, then there's no semantics defined in DTDs or schemas, right? It's just syntax. So there's no reason to have that stuff on. External entities clearly need to be off by default, and entities themselves, hardly anybody uses them. They ought to be off. And then the whole piece that everyone is neglecting is all of these extra protocols that are allowed on a lot of platforms. And really, I would recommend vendors limit it to a whitelist of safer protocols, HTTP, maybe that's it, and then allow people to enable more if they really need them. And as I look around at all the XML parser documentation, very rarely do the different platforms actually instruct developers that XML can be dangerous, that as we parse things, something bad could happen. Very few platforms actually tell people any of that. And so that would obviously help. When it comes to turning off dangerous features, the common complaint, I think, from vendors is that they want to be standards compliant, and all of the stuff is in the standards, so what do they do about it? Well, as it turns out, most of the dangerous features are actually optional in the standard. They're there, but they're optional, and they have been from the beginning of XML. So making it off by default, not removing it, making it off by default seems completely reasonable to me. And if you really want better standards, then work with the W3C and update the standards. That's definitely an angle to go. So that's all I've got. I want to thank Omar for helping me out with testing, and also the support from BSR. Also like to thank the AppSecUSA organizers. They've done a great job so far. And Omar and I are going to be releasing a paper that has a whole lot more details of all the technical minutia that is really tedious but very useful if you're doing pen tests. We're hoping to release that in the next few months, and it's going to have a lot more than I could possibly fit into this presentation. So that's it. Ready for questions, I guess.
So how much of the parameter research was original research, and how much of it was based on the 2012 and earlier work?
Yeah, that's a good question. So I've been working on this for about a year and a half and not progressing very quickly, and then everybody beat me to the punch. So that's the risk with research, right? I can go back. I actually finished a lot faster than I thought I would. So let me go back. So the jar upload thing, I believe that's new. Okay, I don't think anybody's described that yet. The part about wrapping things in C data, I haven't seen that yet. Obviously, it's not a big stretch given the stuff that's already out there. I did independently discover the URL stuff, but those guys published first. Yeah, and I know there's a lot of folks who talk about PHP stuff, and I think they pointed out all this stuff. I think that's an area that folks ought to be looking at pretty closely. PHP allows you to do crazy stuff like read existing open file descriptors, files that are already open. You can just reference them by number and pull data in. You, of course, can pull in arbitrary binary data, right? So now you can get into proc and start pulling back your environment variables for PHP. You can go ahead and take a file and compress it before you base64 encode it. I mean, there's all kinds of wacky stuff that you can do that I just think there's so much attack surface there that combining that with recent PHP vulnerabilities or other things like that could be pretty serious. So also not listed here are a bunch of optional schemes, a bunch of optional URL handlers that are only enabled if you load certain PHP modules, and some of those are scary, like the SSH handler. And so brute force passwords internally, or who knows, maybe a key was set up. I don't know. Things like that expose more. So were there any other things that you were wondering out specifically? Okay.
Any other questions?
We have plenty of time.
Yeah.
Sorry for going so fast. All right. Well, if anyone wants to hang around and take a look at the script, you're welcome to, and I'll answer questions up here privately.
Thank you. Thank you.